here inside the International Space Station Flight Control Room right now. The teams are continuing to track and monitor the cooling loop issue on board the International Space Station. And to kick off our show today, joining me on console is the Expedition 38 Lead Flight Director, Judd Freeling. Judd, first off, thanks so much for joining me here today. Now, we've been following along with this issue, and I know you and the team have been doing a lot of really creative stuff to try and get this loop back up to its nominal settings. What are just some of the things you guys have been doing over the last couple of days?
Sure. As you're aware of, Dan, we're in a spot now with our external cooling loop Bravo that it's rejecting all the heat of the station, and we're trying to get this loop Alpha into a state where we can reject some of the heat of the internal loads. So just to set the stage a little bit there, usually we operate with loop Alpha in a closed loop control mode. So we're unable to do that now. So sort of the efforts we're trying to do is kind of learn how to operate this loop in a kind of an open loop mode where we're using the controllers here on the ground to be the closed loop.
So real quick, just what was the failure? You know, it was with one of the valves actually inside the loop, correct?
Right. So we have a pump module package assembly that's outside. That's the pump that flows all the ammonia throughout the external loops, and on that loop Alpha. And what failed was the regulation of where the hot and the warm ammonia go. Right. So we call that the flow control valve. And the flow control valve is now biased as such where we're only getting a lot of cold ammonia into the system, right? So that means that we've got an interface between the external ammonia system and the internal cooling system, which is an internal water loops that are cooled by water through what's called an interface heat exchanger.
Okay.
If we get the ammonia outside too cold, we are unable to integrate these interface heat exchangers with the internal loops because there's a risk of freezing the internal water loops, and if we freeze the internal water loops, that's a bad thing.
Sounds like a much bigger problem.
Right. It's what ends up happening is those interface heat exchangers have a really small. If you can think of a radiator on your car, real small fins and places where they connect, and if we freeze this, the water expands and would allow ammonia to come to the internal part of station, and that's a really bad thing for the astronauts.
Avoid. And so what have the teams here in Mission Control been doing to try and get around this issue, get the loops back up to functioning to where they should be?
Sure. So the external loop we're still like I said trying to use the team on the ground is kind of a closed loop control. By commanding manually. So we've tried to command manually the loops. We see the heat goes up, and we command little adjustments on a different valve, not this flow control valve, but a different valve that is regulating the cold ammonia that goes into the pump. So we kind of pinch off that valve a little bit, and that allows the loop to warm up, and then we open it up a little bit, and it allows the loop to cool down a bit.
And it's my understanding that this is a loop that, before you guys targeted it, it was one that was just open or close. I mean, this is something that loop wasn't necessarily designed to do.
Right. So this valve that we're manipulating is called a radiator return isolation valve. So as the name implies, it's an isolation valve, and so normally it would just be open or closed.
Gotcha.
So we're using this particular isolation valve in a manner that it wasn't originally designed to be used, and so there's a lot of finesse, and basically what we do is we start it at a known position, we tell it to drive, and then a number of seconds after it drives, we pull the power from the valve, so that fixes it in a certain spot.
And can you give us just a general sense of how that fix has been working so far, or what you're looking at, or if you're going to continue doing that, or are you looking at other things, in the coming days?
Sure. The fidelity that we have here on the ground to precisely control when that valve, starts moving and stops is on the order of about 0.2 seconds, 0.3 seconds, somewhere in that range. we really need the fidelity to be much finer than that. We need it to be on the order of 0.1 seconds.
Okay.
Okay. So the way we can reliably produce that is by putting some software on the computers on board that basically allows us to get that finer control. And so engineers and coders overnight have been working on kind of a software, we call it a patch, a software fix to one of the computers that controls that valve movement. And we've identified the code fix. We're testing it out right now, and hopefully by this afternoon we'll be able to uplink it to the vehicle and then start to again relearn how to manipulate that isolation valve such that we can control the temperatures of the external loop pretty reliably.
Okay. Well, thanks again, Judd. Again, the teams here in Mission Control flying a ship for over 10 years now, and they're still learning how to do new things with it. So we continue to follow along as you guys try and get that loop back into its nominal configuration. Really appreciate you coming on and giving us a quick update on where everything stands right now. Thanks, Judd.
Sure. Thanks, Dan.